Hi, I'm Sara, and I'm a physicist. I actually didn't like math and science very much when I was growing up. I found that they had a reputation for being very intimidating, pretty dry, and I at least thought that they weren't very creative. I had this strong will to hate all of my science classes. The class that I wanted to hate the most was physics. But when I walked into my first physics classroom, it was very exciting and felt a little bit like magic. We could predict what was going to happen in a lot of scenarios. So for instance, we spent a lot of time throwing things across the room or launching them, and we could predict how far they were going to go without really getting any information beforehand, or at least not getting very much information that seemed relevant. So I couldn't stop thinking about physics, but I still really wanted to do something that felt, I don't know, more human or, in my opinion, what was creative. So when I went to college to study archaeology because I wanted to spend my time collecting artifacts and trying to use them to piece together some kind of human history. But I had to take science requirements, so I figured if I couldn't stop thinking about physics, at least I'd take it for a science requirement and get it out of the way. But then college physics got even cooler. In college, we learned about objects that can go through walls without breaking the walls, objects that can be in multiple places at once. We learned that there are ways to make time slow down, or ways where if you go faster, you can get longer or shorter. And I just thought that was wild. I also learned that science actually was very creative and that we spent so much of our time trying to find creative ways to solve problems that it was a lot more engaging than I thought it was going to be. So I also started taking more astronomy classes because I liked physics so much, and astronomy was like labs for physics, but the labs were in outer space. And there were so many more physics things that happen in outer space. You could have black holes that are so big that light can't escape. So when I was graduating college and it came time for me to decide what to do next, I decided to keep studying physics, keep studying astronomy, and I merged the two of them into astrophysics, and that's how I wound up doing a physics/astrophysics PhD at Dartmouth College. Alright, so I said that I wanted to go to college for archaeology, and that didn't quite work out. However, my research, in a way, is archaeology, just it's the archaeology of the universe. It's like archaeology in disguise, because it's in space. So, when people study how the early universe began, they have to collect these artifacts. They have to find very, very old galaxies in the sky, or very, very old stars. But just like in history on Earth, all of these objects are scattered all over the place. A lot of them are broken, and we have to figure out how to reconstruct a timeline with the few and rather fractured artifacts that we have. So my research focuses not on finding the artifacts, but on developing new ways of getting as much information out of the artifacts as we can. My goal in doing this is to construct a really accurate timeline of how the universe was born and how it's evolved since. When many people think about scientists, they think about long white coats and laboratories and safety goggles. But my science isn't done that way. I'm a theorist, which means all of my work is theoretical physics. And since it's theoretical, I don't need to do experiments in the lab. I can do all of them on my computer. Alright, that's all. Thank you for joining me, and I'm very excited to work with all of you this year.